Alright, let's get on to the next question. Alright, so this is a similar question to what we kind of answered. So the impulse experienced by a body is equivalent to the body's change in what? So to understand what this is, let's define some variables. So we know u, let's say that's initial velocity. So that's initial velocity. Then v is final velocity. And then we know from Newton's second law of motion that F net is equal to ma. And then we can kind of use the definition of acceleration and substitute in the equation over here. So for acceleration, we know that it's final speed minus initial speed over time, and we're going to substitute this into here. So F equals m vu, and this will help us. This kind of derivation will help us explain what the impulse experienced by a body is equivalent to. The body's change in what? So going on, we can multiply both sides by t. So F t equals m, and we can expand out the brackets, v minus m u. So I'll clear some space up top. Alright, we have ft on the left side is equal to mv minus mu. So mv minus mu is just m, because we have the same mass. The mass doesn't change, times the change in speed. And mass times the change of speed is just the change in momentum. So we know that the impulse, which is represented by force times time, so I'll write that over here again. So the impulse, force times time, is equal to the change in momentum. So here our answer is change in momentum. And p, the variable p over here, is representing the change in momentum. And delta here is just change. So change in momentum. So here, impulse is a quantity that is dependent on the applied force and the duration of the force by Newton's second law of motion. So F net equals ma, where m is the mass and a is the acceleration, which is equal to acceleration. So final speed, initial speed over time. They do the substitution and they get that impulse is equal to the change in momentum. Alright, so great job. Correct answer. So we'll mark that answer as correct.